This video is going to look at scientific notation, and we're going to look at why it works and establish some mathematical foundations to show you that it is not just a trick of physics. We established in the lecture notes that scientific notation is necessary due to the fact of the limitations of the human mind in grasping numbers that are ridiculously large and ridiculously small. For this video, we're going to look at those numbers that are ridiculously large, in other words, those that have positive exponents when expressed in scientific notation. So let's look at 4,328 and establish that it is indeed mathematically equivalent to 4.328 times 10 to the third power. We'll do that by expanding the exponent on the factor of 10 into its component parts. And if you don't follow why that expansion is correct, please go back and review the exponent rules video. And then we will expand, and then we will complete this process by executing the successive multiplications. In this case here, we have taken the first factor of 10 and multiplied it by 4.328, giving us the 43.28 times 10 times 10. And we will do that successively, giving us the remaining factor of 10. And then the final execution, we do indeed see that 4,328 is what we obtain on the right-hand side. And so we are equivalent here. Let's take this and let's work the reverse process in the form of an example. Let's see if we can execute this process in reverse to obtain 52,487 in scientific notation. And so we will start by extracting successive factors of 10. And as you see here, this has the effect, every time we extract a factor of 10, this has the effect of moving that decimal one place to the left. And so we do this successively, and we see that we get 524.87 times 10 times 10. With the next step, we get 52.487 times 10 times 10 times 10. And then we have a final extraction giving us 5.2487 times 10 times 10 times 10 times 10. And when we have like bases, we recombine them as a single exponent expression. The 10 times 10 times 10 times 10 gives us the 10 to the fourth power that you see in the expression below, and that does indeed match what we need. In the lecture, if you remember, we would have taken the decimal and moved it 1, 2, 3, 4 places to the left, giving us the corresponding factor 10 to the fourth power.